Maybe you position him now.
Sir, shall I start the session, sir? Dr. G.Saravana Kumar, sir.
Yeah. So
Okay.
see, if you want my video, I should be in my Mac, but my Mac has some PowerPoint issues. Otherwise, I can shift to my other system also, wherein the videos and other things will play properly, but it doesn't has a camera. That's the only thing. Yeah.
Okay, sir. Okay, sir.
So I think we will continue in this. In case I find it any issue, then probably I can shift to the system. Okay.
Okay, sir. Okay, we will try it, sir. So once again, a warm welcome to all the participants of our AIST sponsored faculty development program on design thinking. So now we are in the day 3 of session 8, and today's speaker is Dr. G.Saravana Kumar, sir, Professor IIT Madras. So now I invite Dr. G. Ganesh Kumar, Professor, Department of Mechanical Engineering, Sri Manapala Engineering College, to introduce our speaker, Dr. G.Saravana Kumar, sir.
Thank you, sir.
Good morning.
Good morning to all. First of all, this is the third day, 8th section of our ATAL FDP on design thinking, organized by Sri Manapala Engineering College, Puducherry. So I would like to thank the college management, the respected Director cum Principal, Dr. V.S.K. Venkadajalapati sir, our beloved Professor and HOD, Dr. K. Velmurugan sir, for giving the wonderful opportunity. It's a great pleasure for me to introduce our speaker today. Dr. G.Saravana Kumar sir is a professor in the Department of Engineering Design, Indian Institute of Technology, Madras, Chennai. Sir is well qualified, holding the B in Mechanical Engineering, the 1997, the University of Madras, and ME specialization in Building Engineering, 1999, REC Trichy. He did PhD in Mechanical Engineering, 2004, the IIT Kanpur. So one proverb, so no tech, so without make, sir has proved that he doing the research in CAD, design optimization, design for the additive manufacturing, the orthopedic, the biomechanics, and the biomedical image processing. He has published more than 40 international journals, the recently published the Asian Spain journals and the Journal of the Biomechanics in the year of 2020. Sir has attended more than 85 referred conferences and covered the major areas like mechanics, the electrical and electronics, the computer science on his research. He has also published more than 2 books on, so one is the geometric modeling methods using the point cloud data. The second one is a computer aided engineering design. Sir started carrying the research association, the Department of the Mechanical Engineering, the IIT Kanpur, then switch over to the assistant professor, the Department of the Mechanical Engineering, the IIT Guwahati. The assistant professor, the Department of Engineering Design, the IIT Madras. After that, sir, the hard work, sir has got the associate professor, the Department of Engineering Design, the IIT Madras. At present, sir is working the professor, the Department of Engineering Design, the IIT Madras. Sir has received 5 sponsored projects. So one is a DRDO, the India, the imprint India, the academic year of 1917-20. So DST in India, the academic year of 2011 to 2014. The Autodesk India Private Limited, the academic year of 2011 to 2012. The DST, the fast track the project academic year of 2010. So he has the various level the student guided. So the first one is 8 PhD completed. Next one is 6, the PhD ongoing. So 3 MS completed. The 3 MS is ongoing. 30 MTech and a dual degree. the projects are completed. Sir has organized security short-term courses, the optimization for engineering design, the computer-aided design, the rapid prototyping, the development. The another one more is the National Conference on Mechanics and Mechanism, 2006. So he has invited the various colleges guest lecture for Kerala and Tamil Nadu state. He has given the great lecture the various discipline information of 3D printing technology and model the application Indo-Australian workshop on the advances materials and additive manufacturing. So digital modeling and the fabrication, the manufacturing, the reverse engineering and eligible and for rapid prototyping development. The last one is the intelligent, the computing to the clean energy. Next one is yes, the various professional bodies like the American Society of Mechanical Engineering since 2006, a life member in the Association of Machines and Mechanism since 2009. It's a life member, the Rapid Prototyping Society of India since 2008. He has received award and honors. So sir is award the National the Innovation Council of 2012, the Young Engineers Award in the Mechanical Engineering. It's a discipline from the Institute of Engineers, India, Kolkata, 2009. So third, the best solution proposal in the area of the biodegradable tissues, especially for the creating the custom organs. He has received one US patent granted with the intellectual, the Venture Asia Private Limited, Singapore. So last but not least, he has a very sincere. Sir has received the gold medal for the best outgoing student and the consistently the holding the first rank. So during the entire UG course period from Department of the Mechanical Engineering, the Government College of Engineering, Salem in 1997. So this is a brief introduction. Now I request Dr. G.Saravana Kumar sir to address us the gathering. Thank you, sir.
So thank you for the introduction. It was not brief, it was too big, but anyway, thanks. Sorry for the delay. I had some issues with our server in terms of connecting to the meeting. And very good morning to all the participants of this short-term course on design thinking. So I have been working in the area of engineering design process, and also both from teaching as well as from various product design for the last couple of decades. So I would like to share some of my experiences in teaching design to our graduate and undergraduate students, and I had made a presentation to discuss about how we go about teaching the various concepts of design to the students. So that is what I had focused for today's talk. So let me share my screen. So is my screen visible?
Yes, sir. Yes, sir. You can.
Okay. So I hope the screen is visible. The size is okay, right?
Yeah. Okay, fine, sir.
Yeah.
It's okay.
The full screen mode has some issues, so I will be sharing with in this normal view. Okay. Yeah. Thank you. So as I said, my talk will focus on my experience in doing this design course in terms of teaching the design to the engineering students. Just 1 minute. Just give me a minute. Yeah. So I will talk about engineering design process as such and how we have framed a curriculum in IIT Madras, which places emphasis more on the synthesis, design synthesis, as opposed to engineering analysis. Most of our curriculum, if you would see, places much emphasis on engineering analysis. So given a design, we know how to do the analysis and try to figure out its performance and evaluate it. But how do we come up with the design in the first instance? That is a process which has not been focused for a long time in our engineering curriculum. Unfortunately, this has led to a lot of engineers who do not have the appreciation of the design process, and this has been realized, and over years a lot of curriculum change has happened, and now we do see that most of the engineering colleges are able to bring in this design thinking into the curriculum. And in that sense, this FDP, I hope, will enable the participants to think think in terms of how do we teach design. Teaching design is really difficult. In fact, many people say that design cannot be taught, but you have to learn, and that is why we have placed a lot of emphasis on the design practice along with some theoretical concepts. And I will share some experiences how we do this design pedagogy in IIT Madras. So this anyway is about my department. We are an interdisciplinary group of faculty, and our focus is mainly on automotive systems design and biomedical systems design. Our students get a dual degree in engineering design, and then they specialize either in automotive or biomedical. And our group of faculty is interdisciplinary people from mechanical, electronics, and even we have guest faculty coming from arts and history, so that they teach about arts and history, because design, as you will see, has evolved from the arts. So we have been designing a lot of architectural structures, and design has a lot of connection with art, and we need to have some appreciation of art as well if we want to design systems and products. So the process of design, as many would appreciate, is about what is the form and what is the function. If we take any product, what we see is the form, and the function is what it performs to satisfy the needs of the customer or the persons who would like to use that product. The function could be aesthetics, the function could be a performance of an engine, in case it is a mechanical or a structural component. So the function and form are the two critical aspects of design, and trying to understand the connection between these is the understanding of the design process. So our entire curriculum, I had just tried to give a snapshot of how we have gone about doing the curriculum, from linking the basic science and then the engineering, the materials, the understanding of mechanics. All of this is nicely tagged with these two concepts. So right in the first year, we introduced them about this functional and conceptual design, wherein they have an appreciation of the form and the function and how this is embodied in a product, how this is laid out, the function and the form is laid out to create the product architecture. So they have an appreciation of this, and then they start connecting the fundamental engineering courses, whatever they learn, let's say calculus to optimization, linear algebra or physics or materials, and later on, let's say the analysis like heat transfer or fluid mechanics. They are able to connect it to the design of these form, the detailed design of this form. And we also have a lot of courses, as I mentioned, to emphasize the importance of art and art appreciation. Over the years, we have been able to refine this structure, and we do see a good number of people who have become entrepreneurs, who have become product designers and product developers. So our alumni is like the most I would say one of the good examples is the electric bike company. So Aether Energies, I think some of you might be aware of. They are born out of our department, and they had gone on to create an ecosystem and an industry to create these electric bikes in India. And there are very many other examples. A lot of our students have become entrepreneurs, and we believe that this structure, whatever we have put in place, has helped them to be designers, to be entrepreneurs, rather than just be engineers. So this is just to give you a prelude to what we have been able to accomplish over a decade or more. We have kind of graduated more than 10 batches of our students, and most of them are very good in their respective fields. So this particular course which I would talk about is the conceptual design, the functional and conceptual design, and the product design. The lab associated with this course is what will be our focus, and we introduce them the connection between this form and function in very many ways, right from doing what we call as the reverse engineering, that is knowing a form or knowing a component and then trying to go back to understand its function by trying to understand how individual subsystems or components are connected and what are their individual tasks, and how these tasks, when combined together, they give the overall function of the product. So we place a lot of emphasis on product tear down analysis and developing the understanding of the connection between the function and the form. And as I had shown, from the entire product development cycle, we focus on the early stages of the design process, which is where we have a lot of synthesis. As you will see later, when we come to design details and testing, refinement and production, that is our conventional engineering. The scope lies in our conventional engineering analysis. But these early stages of the development is where the idea of innovation, the emphasis of developing these concepts is placed. And these the students are made to understand the significance of the need for a very detailed and a thorough system level design and thinking about this form and function and how we can develop the concepts. So as part of the lab, we have several activities to place emphasis about the different design processes. So we start right from building the teams. Even team building exercises are given to them so that as a team, they know how to work and what to expect, or how they can assign the task to the different members, whether it be the leadership role or whether it be more of say communication within the group. So they know how to gel together and work as a team. To doing a lot of the product tear down exercises, right from consumer products to engineering components like engines or drive shafts, to consumer products like any of the electronic or mechatronic components that are used in home or in offices. So they do this product dissection and try to understand the form and function. And also they do a course project wherein they can exercise whatever they learn in terms of designing new products or trying to find a variant to the existing product. So we try to also bring in industry wherever it is possible, because a lot of design problems are there in the industry, and sometimes these young minds, the students, right, just after their schooling, they have just entered and they are in their first year, and they are quite dynamic, very energetic, and they can also think very wildly. So thinking about the concept development, uh, when we as engineers, we know about the practical constraints and considerations of the design. Our ability to think about the various ways of achieving a function is diminished. In that sense, our minds are locked and channelized to think in a particular way. We think that this is only possible, or this is the way it has to be done, because we have not seen another way of doing the same thing. So our minds are constrained, and possibly we cannot think very radically from what has been done. So we know an engine has to work this way and it has to be like this because it is based on science, it is based on engineering. But there is a possibility that there is a scope, there is a design space which has not been explored. But we fail to explore that design space because our minds are constrained to think in a particular fashion. So maybe these first years, right, when we have not taught them too much engineering, not too much of fluid mechanics, not too much of thermodynamics, or not too much of, say, solid mechanics, they can wildly think. They may even come up with concepts that are practically infeasible, but later we can tell them, okay, these are the things, these are the constraints coming from your science or engineering, and thereby maybe some of these concepts are not feasible. But sometimes it is out of these several I would say radical thoughts, some radical thoughts may be feasible yet which has not been explored, and that is what will lead to some new products and new concepts. And that is why we see once in a kind of blue moon, we suddenly have technologies which completely change the way we work or we do. So if we think of communication, we have always been routed to wires as a means of communication, but the thought of wireless communication was a very big radical change. In the same way, in each domain, if you take this Internet of Things and how we do commerce today, all of these are radical thought processes which has come at certain points of time, because of some person thinking very radically. So how do we bring about once in a blue moon type of radical thought process? Rather than doing it that way, can we do it in a more systematic fashion so that it becomes a regular way of thinking about design and going about the design process? So these things we try to place emphasis, we discuss with them, and we bring in some industry problems so that they also know that whatever they are doing is practically connected, or there is a practical use of this design thinking, and they will also have a satisfaction that they were able to apply some of these thoughts into some practically relevant problems. So that is how we go about teaching, or making them learn through activities. Okay. So I am okay with intermediate questions or stopping and discussion. So please feel free. It's not a monologue. So how does this work here? Like hand raising, or how is it in Zoom? Sorry. Hello.
Sir, at the bottom, the participants list is there, and then we can choose if we want to raise our hand from there. The participants can do that. And for you, it will be appearing on the top of the screen as a notification if somebody has put something in the chat box.
Yeah. So I'm okay to the interaction in between. The participants need not wait till the end of the talk to talk about these things. So I'm okay if to have interactions as we go along. Okay. Yeah. So let me go back to my presentation screen. So what I would do now is take you through some sessions, would just discuss how we do this pedagogy of design thinking and design process with our students. So initially we do some very simple team building exercises. We give them very simple problems and simple materials to work with, and ask them to accomplish. So this is the first time probably they are working as a team, and so they try to understand each other's way of working, each other's way of thinking, and try to see how within a given constraint they are able to achieve the objectives. So typically in any engineering project we will have constraints coming in terms of resources, so time as well as say materials or the cost that goes into the development of the product. So that comes as a constraint, and then there are certain requirements from the function what the product has to do. So they have to achieve this. So this is simulated using a small exercise. So we give them materials like paper, cardboard, and ask them to do some design, like designing a tower, let's say, to take some load. As you see in this picture, they were asked to do a design of a column structure using the paper material that is given to them, and the constraints have been given in terms of sizing, or in terms of the load that it has to carry, or in terms of the wind load it has to take. So these constraints that typically we will have in an engineering product are given to them, and they are asked to build with the given material. And it goes more as a fun activity, so that they also do this to understand each other's capability, and how to communicate within the team, and gel together and work as a team. So this is one of the first exercises that we typically do to form an engineering design team for the the product design exercises that they shall be doing later on. And then what we do is we have a series of product dissection or product tear down labs, as I had mentioned, where they try to understand what is the product and what the customer sees. So they use the product. So let's say if I have a mixie, then they try to use it to see, okay, what are the functions of this? Or if there is a water cooler, they try to use that system and try to understand what this product is doing. And then we pose them questions like, how is it doing this? Or whatever is the function that this product is doing, how is it doing? So there, so they try to understand product dissection. Hello? So sorry, there is some disturbance, or I thought there was some question. Yes, I am having practical examples. I have taken some 4 or 5 practical examples. I would be discussing that. Okay. Yeah. So what we ask them to do is understand the concept of function and form relationship by trying to see the subsystems and understand each subsystem, its task and how it is connected. We ask them to discuss about manufacturability, constraints like DFM, concepts of design for assembly, design for manufacturing, design for quality, design for cost. These are introduced and we give them for each week, we give them one focused activity. Say on 1 week on a given product, they would try to understand by dissection the manufacturability aspects. What is the material, how the different components have been manufactured. And we also ask them whether there could be alternate ways of manufacturing. Let's say if it is a plastic component and it is injection molded, are there other ways of doing it? Or if there is a exercise on design for assembly, we will ask them whether there are other means of assembling these components, and we introduce these concepts. Though in a more formal way, they will learn about these concepts more in detail at a later course, but they have a practical understanding and they appreciate that these concepts go into the product design using these exercises. So these are some things that we do for each of the product dissection exercise that we give. I just thought, I will just take one example. So here you see that there is a blender. So typically we have about 60 students. So what we do is we have about some 10 to 12 products and a team of some 4 or 5 students. They cycle through this for the whole semester, wherein each product, so one group would have taken this blender and it would have, that group would have understood the design for manufacturing aspect. But the next week, another group will take the same product and probably discuss about design for assembly. This way, we ensure that the scope for each team with respect to each product is different, and there is no repetition or monotonicity or something that they can try to understand from another team. And this also places an emphasis that between teams they can discuss later that this is what they did and this is what they have tried to understand. So we try to do this mix and match of different activities with different groups, ensuring that there is no monotonicity in the whole exercise for the entire semester. So they understand the product dissection, the components, the method of manufacture, the assembly, as I said, and the cost perspective, can some components be replaced, or can some components be combined? Some design for assembly concepts can be used, design for cost concepts can be used. So these are some things that they learn. And one other important activity that they do as part of each product is connecting this function and form. So we ask them to build what is called as a function structure. If some of you have been doing this design course teaching, so there are these concepts of function structure. One of the earliest thinking in terms of this, and in terms of the presentation of the way of thinking was done by the German design pedagogy people like Paul and Bitz. Their book is very famous, the engineering design process book by Paul and Bitz. So that introduces these concepts of creating function structure. So every product is seen as a flow of material, as a flow of energy and flow of signal. So an abstraction of each product in terms of what is the material, what is the energy, and what is the signal. So every product is thought as an embodiment of these three, and a flow of this structure is created. This creates an abstraction of the product in terms of the function. So they move away from the form to the function by understanding these connections, and that we give them as an exercise, like what is happening to energy, whether energy is being converted from one form to the other, or its magnitude is increased, like force is being converted to torque, or electrical energy is converted to mechanical energy, or the material is being transformed, like a material is taken in bulk form, it is getting into pulverized form, or information is embedded, like quality concepts. So all these are
रेगुलर जाना
yes.
उनको कंटिन्यू रेगुलर जाना
Hello? Hello?
Tell me, sir.
No, so sorry, there was some, I thought there is some question, so I'm just trying to shift between the chat window and
No question, sir. You can proceed, sir. No question.
yeah. No, whenever there is an audio response, I just try to pause and see if there is any questions or any discussion. Okay. Yeah. So we ask the students to create these kind of function structures where they understand the individual tasks that needs to be performed, and what is the flow of energy, signal, or material, and they get this idea of systems thinking, because any product can now be thought of as a transformation of energy, material, and signal. A product is trying to transform this three inputs, basically signals, energy, and material, into certain outputs, which are again energy, signals, or materials. So we bring in this concept of system thinking by asking them to create these kind of function structure. Like here, you see an example of a steam iron, for which the students have created the function structure where energy, like in the form of electrical energy, is given, and material here is the cloth that is getting transformed. A cloth with wrinkles gets transformed to a cloth without wrinkles in the process of ironing. Or let's say water is used to give, say, additional steam, so that the wrinkles, hard wrinkles, can be removed. And energy like human force or pressure is also needed in this process. So they try to connect all these elements and signal in terms of where you want to iron. Like the human hand itself is the signal provider, because you are taking the iron to the place where you want to remove the wrinkles. This is just a very simple product, but this is how they understand that any product can be thought of as a system that is transforming energy, material, and signal. So this is reinforced by giving lot of such exercises. For each product they try to create such kind of structure, and then they try to create some layouts, the geometric layouts, how these individual functions are embodied as subsystems and how they are placed, so that they have some idea about the product architecture. And they can also think about product architecture variants, how to create different variants, like one can assemble the products or keep them in a vertical orientation or in an horizontal orientation, or how do they place these different components in the context of usability, or in the context of maintenance of the component. So they can try to understand how the geometric layout places an significant role in terms of designing some of these attributes of the product. And we also place emphasis on this concept generation. So once they do certain number of these product dissection and understanding the form and function mapping, we ask them to do this to generate new concepts. Let's say given a product and they understand the different functions to be done, can they create a new design? Can they create a variant of this design? Say given a product, can they think of doing this function in a different way? So these concept generation ideas are then emphasized, and as part of one theory lecture hour, we also teach them some tools that they can use. Like there are QFD tools that they can use to generate the concepts, or they can create these matrix methods, and all these methods are taught to them as part of a 1 hour contact hour, so that there is not too much of lecture, but we do tell, okay, these are some of the tools that probably you can use it along with your product design activity. And in these lecture hours, we give them some idea about tools. Let's say we teach them what is TRIZ and the inventive principles of TRIZ. Let's say the 40 inventive principles of TRIZ and how that can be applied in some context. If I take a fridge just as an example, so TRIZ has one principle saying that just whatever is just change the layout, or whatever is above you change to below. This is one good example that I always tell them. So we always see fridge with the freezer section above, and the normal cooling section is kept below. So and we have been, as Asians, as Indians also, we have been using this kind of fridges for quite a long time. But today we see BMRs, bottom mounted refrigerators. If you see a lot of companies have come up with this BMR option. Particularly it is more prevalent in the Asian context. So if you see the genesis of this, the Western world typically consumes a lot more of non-vegetarian food as compared to a vegetarian food. So they would like to have the access to the dairy and the meat products easily. So they keep everything at the hand access level, which is at a higher level, and vegetables and other compartments is kept low. So once in a while or whenever you want access, you can bend and take it. But we as Asians predominantly, where we a lot more vegetarians as compared to West, it would make sense if we have the vegetable compartment above and the freezer compartment which goes below. So this comes from a TRIZ concept. Like, okay, why not design a component where whatever was in the top, you just put it in the bottom. This is just one inventive principle, and there are a lot of some 40 inventive principles that you can apply. So these kind of small examples we ask them to do or realize in the product, so that they understand that some of these inventive principles can be used for the product design purpose. Like here, these are the different things. I just gave you an example of TRIS, but we asked them to do several other exercises, like brainstorming, the conventional way of team-based activity, and going through the concepts, and using some classification tables, more scientific schemes of understanding and differentiating the concepts. Many of these things are inbuilt as a part of the exercise, rather than just keeping it as a theory. They practice with these exercises. So this is just a picture. I do not know. I do have a video, but unfortunately, let me see if I can. Okay, nevertheless, it's okay. It's okay. So we asked the students to think and come up with a lot of these concepts by guiding them, but making sure that the entire brainstorming exercise happens from the students end. And we have done this kind of exercise sometimes as a whole day or a half day activity. If it doesn't fits into our the regular curriculum, we push it to, let's say, weekend, like a Saturday, so that they can spend at least say 4 or 5 hours together to think about a given product, because typically our lab sessions are limited to 2 to 3 hours of sitting together, just to handhold them in this process of design thinking. At least one workshop kind of activity we do maybe in a weekend, so that they know that this is what they can do, and later they can practice for the various other products at their own convenience, and their own ways of meeting and discussing. So this is just an example, like for a tea maker and an electric brewing machine, where these are the system diagram of what is the input and what is the output, and they create the function structure for this. And for each of the function, they try to create the embodiment. Like here, I have just shown some three major sub functions, like dispensing water and leaves, heating the water, combining tea and water to make the the concoction. Just 1 minute. Hello. Divya, I'm in a talk. Huh? I will take the call later. Yeah. Sorry. Yeah. So the three major sub functions I have just listed, and for each of these, the team comes up with different concepts. Like if I have to take dispensing water and leaves, so these are the ways to dispense different mechanisms to dispense a tea. Like you can use a screw type dispenser, where a known quantity of tea can be dispensed if I give a particular rotation. Or I can have a sliding gate, where a known quantity of tea can be taken from the hopper to the for making the tea the decoction. Or you can have a simple reciprocating piston mechanism. So they think about these concepts. Or if it is about dispensing water, they come up with these different concepts. So each member comes with a concept, so the then discusses with the others and improves the concepts. So concepts like this 635, where each person comes with one concept, and then others comment on that, and then concepts are merged together to create better concepts. So these things are practiced by the students. So different mechanisms for, say, dispensing the water, like using a bellow air, or using a motor and a pump, or using a steam pressure to dispense the water, and then heating the water, different mechanisms, either induction heating or traditional the immersion heater and so forth, or for combining the tea and water to create the the final the tea. So all these things they do. This is just an example of a product on which some team has worked on. So this happens throughout the semester, and along with this we give them some design project, so on which they can continuously work for the entire semester. So the scope of the product is given to them, and they work on the product design, mainly the conceptual development. As I said, the detailed engineering, we don't give them projects which needs lot of engineering design detail, but rather it involves lot of conceptual exercise, lot of design synthesis rather than analysis. So we choose and give them activities like that. So this is 1 year's activity I just thought I would share. So here we gave this exercise of walking on the water. So what you see here is a small insect that actually walks on water. If you would have seen, it is a small insect, and we say that this product is motivated by this ability of this insect to walk on water. So whether it is using the concept of buoyancy, or whether it is using the concept of surface tension, so those things they can figure out, or some product may use one of these, or together both buoyancy as well as surface tension. So they try to figure out that, and they try to embody this into the product, and they come up with different concepts. So here here is what you see. So we took the students to our swimming pool, asked them to demonstrate the product towards the end of the semester. Okay, so it's both a fun-filled activity, but as well as teaches them on the various concepts of the design. Okay, so keeping in view of the time constraint, we will skip this video. So I would take you through a few more project examples, and some projects are being given by industry, and how the students developed the concepts. Like here, this is a concept of having a public shared bicycle. So we know that most of the bicycles have been designed for personal use. The design consideration for bicycles is that it will be used by the person. So the amount of usage may not be very extensive, and thereby the requirement for maintenance and all of that. So every aspect of the product is tuned considering the cost, considering the usage, and this product has been traditionally designed considering it as a personal usage. And now with the shared bicycle concept, many of the Western countries, it is there, and in India also it is coming up. And in fact, a lot of such exercise has been done. But this company was interested. This was in fact sponsored, or it was the problem statement was given by a company or an entrepreneur who wanted to redesign the bicycle considering various issues when we use this as a shared bicycle concept. So one of the important things that they were worried was about the maintenance, because these cycles are mostly, they will be parked outside, and they will be exposed to the uh, environment, the severities like your rain or anything, and that's a lot of components. Like typically most cycles we will have a chain and sprocket mechanism. All of that will need a lot of maintenance if these are kept outside. So and most of the times we will see that whenever we take out a cycle and go, one of the components or the system that most of the time creates the problem is the chain and the sprocket. The chain will come off, or it will slacken, and we don't expect an user to meddle with it or maintain it, because anyway it is not his personal bike and he may not take care of it. So considering all these aspects, the students were to come up with a lot of different ways of thinking about this, and many concepts came. Here you see a brainstorming session. So what we do is like we bring in these industry people every now and then during the entire semester at different stages. So let's say they first identify the problem, and then they are ready to discuss about it. We have one session with the industry people, and then they do brainstorming, develop some concepts. We have another session with them. So they provide because when you connect the industry people, the constraints comes from them. But when these students do the brainstorming, they do a very wild exploration of the design space that is available. So this way we funnel out the ideas. So they think very wildly, they start with a lot of ideas, then slowly we funnel considering various engineering practical constraints, and we come up with some one or two concepts which they can further explore, create the proof of concept, and then they go on to manufacture. So here you see a drive shaft kind of a mechanism which is being used in a cycle. So now I think probably even you would have seen some advertisements coming up even in our TVs for cycles with without chains and sprockets. So these are some concepts that these students thought of. And there are several examples like here. Let me see if this runs. Sorry, this video. Sorry, I think this video may not run. Okay, anyway, it doesn't matter. So this is another example of a product which is used to flip pages of a book, so that it can help a person, let's say, temporarily handicapped because he met with an accident and he's not able to use his hands, or he could be a permanently disabled person who may be interested to use this device to flip the pages. Or there are other scenarios like you can think of this digitizing. So there are a lot of old records are available, and we would like to have a digitizer where you want to flip all these pages sequentially, and you would like to take photographs and digitize the old hard copy documents. Or in the context of the stage music play, you have the music notes page, and every now and then you don't want the player to flip the pages, but rather you can have a device which flips the notes for him while he can continuously play. So there are very many areas or application domains where this could find find a use. And in fact, the students came up with several designs. I would go through the process, and then there is this tricycle. You would see that the products that are typically undergoing lot of evolution are the products where there is a market. So there is also a concept called designing for 90% of the people. So most of the products that if you will see in the market, or most of the industries that are associated with this design and product development activity, they actually design products for 10% of the population. There is a 90% population whose needs and whose requirements are never thought of in terms of the product design. So if you take a tricycle, like the tricycle which is used by the handicapped people, it has not gone through any evolution. Probably 50 years back, whatever was the cycle, the way it was, a tricycle was there, probably we have on a very similar state. Or there are products very high end, and which can be used by people in the context of, let's say, where I have a neat pavement, or within the office environment, or I don't need to go too much into the normal roads and the rural roads that I have. So I may have a ramp, and I will be going from my office to my car, which is also specially designed to accommodate my wheelchair. And probably I can drive and then come back. So there are Western concepts or designs which are based on that, but not that they will be applicable directly, let's say, to someone in a rural India who has to commute from his home to his workplace, and probably he is handicapped and he cannot walk, or he cannot use the regular modes of transportation, and people who use such kind of tricycles. So there are several examples. This is just one product where these products never evolve, or they are not designed because there is no money in this. And these are some things that also we try to tell them, or that there is a scope that you can think about design thinking. You can think about improving the life of these people who will be using these products. So here is one example of a tricycle which the students modified considering the ergonomics, the comfort, balancing, the whatever concepts of vehicle dynamics that we use for, let's say, designing the high end bikes. Those kind of concepts, balancing, that can be applied here, because this is more critical here. If the person actually falls off from this, particularly when one of the wheels goes over a bump or a pothole, what is the dynamics of this where this vehicle, whether it will topple or whether it is stable. So all these concepts the students actually applied on this product. And the modularity, how to change the let's say the seat orientation, or the distance between how he pedals with his hands to where he is sitting, because each person, the level of disability, their physical structure, everything is more different. So a lot of these concepts they applied in this product. You see another product here which we call it as a Hue motor. Many of these products, by the way, they have gone on to get the patents, and students, we also give them exercise on how to patent, at least to know that there is a way to protect the ideas, either for commercial purpose or even for licensing, at a very low cost, but you have to protect your ideas. So those concepts also we tell them. So many of these student teams have also done the exercise of documenting the design, so that you can present it to a patent office and attorney, defend your ideas, saying that this is novel or this is different and so forth. So that kind of exercise also these students are exposed to, intellectual property protection kind of activities, because these are all things that they will probably do as an entrepreneur, as a product developer later on when they go on to create their own company. So here what you see is another example of Hue motor, where this device is used to help small construction activity like single floor material. Typically you will see that they will put a ramp or a scaffold, and the people will be carrying these material, and instead of doing that, this is a simple device which can help in lifting the material. Okay, so maybe I will go into little more of details of how they did this, maybe in one product. Like if you take this page flipper, they came up with the different functions that a page flipper has to do. Like it has to hold the paper, it has to then lift the paper, and so some 2-3 functions that it has to do. What are the different ways of doing it? Let's say if it has to lift the paper, I can use a roller, a friction wheel that can roll over the paper. Then what are the pitfalls of that, whether the paper will get damaged because of that. If it is a vacuum suction mechanism, how that can be used, what are the pros and cons of that. Or if it is using electrostatic charge, like sticking, using this electrostatic charge, or using a tape adhesive, all these concepts. So some may be employable, some may not be employable in some context, or each will have its own pros and cons. So they develop a lot of these variants. So let's say for each of the subsystems they develop 4 or 5 concepts. You can see that by permutation and combination they come with a lot of variants of the design. Say, let's say this is another mechanism like turning. Again, they came up with some 3-4 ways of turning the page. Or if it is clamping, then there are some 2-3 ways of clamping. So now itself you see that for these 3 main functions, they have these different concepts, and every permutation can be now checked, or they can create prototypes, embody it, or do the analysis. So all of this they did. And so what I will do, I will, these are some analysis that they have done, and some embodiments, simple starting sketches. Then they went into CAD, they created the layout geometry, they put the required circuitry, and they created different prototypes. Like this is the first prototype. Unfortunately some of these videos are not playing because of I'm using a Mac system. So you can see these are the details of the design. They prototyped it, used the 3D printers to quickly get the components, looked at the aesthetic part of it, did better products. So all this like 2-3 iterations of going through this whole exercise. So this is another example. So typically you will see that there are 2-3 actions or mechanisms that are required. Like if you even take this the tailgate, you will see that you will have a mechanism to lock, you will have a mechanism to hold the the tailgate, and another mechanism to do the lifting, like this hydraulic or a pneumatic lifting. So you will see that there are all these components needs to be attached to the glass. This is again a problem coming from an industry. I just thought and I'll show some of the problems that the students worked on. So the problem statement given to the student was, now I have to drill holes, or I have to do this design for manufacturing. Basically, the idea was for the students to understand design for manufacturing, that on this glass they have to fix the lock, they have to make provisions for attaching the hinges and the lift, the pneumatic lift mechanism. So all these will need post processing, and to reduce the cost of the product, we would like to do a DFM and A analysis, so that you can reduce these the connection. And the students actually came up with a single mechanism which will do all the jobs. It will be a hinge, it will also be a lock, it will also provide the required lifting and holding into a given position. So like a bistable mechanism, it will open up and it will be stable in one position. All of this as a single component. So that was the concept developed by these students. One integrated mechanism to do this. This is that example I talked about, the Hue motor. And this device again went through several iterations of creating this. And the product was of interest, and in fact the Building Material Technology Corporation, they even funded for further development to see if this product can go into the market, and some small scale construction activity builders can use this. So you can see at least 4 to 5 prototype versions built by the students, tested in the lab. This is another product again from the construction industry, which was motivated that now that we have a machine which can use the strongest muscle of the human body, that is the thigh muscle, for the pedaling action, which will be converted into a power source. So in this case, it is used for lifting the weight, but the same force and the power that is generated can be used for another activity, which is bending the rod. So this is more like an attachment to the same machine, which was pursued by another set of students, which is used for bending the rods. If you will see that this is one typical activity, and it is very strenuous, because he is using his hands to apply the force and bend these rods. So here you will see that this table and the drive mechanism is connected to the powerhouse, which is the Hue motor, and one can do the rod bending activity using this. So again, this is derived from the need that can we reduce the injuries that may happen, like muscle injuries, muscle tear, or muscle pain. All of that could be avoided. So this is again testing and improvising the product. So we bring in the users. So in this case, the construction user, they give us the feedback, the students learn from them, they understand what to improve on the product. This is another interesting problem. Just I picked up few problems. There's a plethora of problems that the students have worked over these years. This is another problem from industry to reduce the industrial noise. This was in a manufacturing plant where some tubes are falling from a setup, and the noise levels are quite high. So industrial occupational hazard, I think 80 decibel or anything above that is hazardous, and in this plant the decibel level was more than 90 decibels. And here the students came up with a passive device. So no hi-fi electronics, no power source and all of that, but it's a passive device wherein the falling of the tube, the energy that is available, that itself is used to lower the tube and place it into the trough, and reducing the fall height. So different ways of reducing it. So they brainstorm okay, what is the source of noise, whether it is the falling height and one metal hitting the other. So all of this they addressed individually and created some concepts which could be implemented in the industry. So these are some examples that I thought I would share with you. So quickly, these exercises are also, academically rewarding. Some students, at least those who are interested, they also pursued this in terms of at least conference papers and, posters and so forth. A lot of patents, patent documentation. The students are involved also in terms of these kind of intellectual activity, along with what they do. Yeah, I think so that's all I thought of discussing, so we can have some interaction. I would like to thank my colleagues. So this is not just a one-man show. I'm just part of a team, and I have my colleagues like Sandeepan, Paraniappan, Ramu, and a lot of students, project staff, workshop staff are all involved in whatever activities that I have tried to showcase to you. So I would now ask the moderator or whomsoever is there to help me in interacting with the participants, or talk to them, and have any questions answered. Yeah.
Thank you, sir. You are really taking a session in a different way. You have explored what are the projects, student project, how it should be converted into publication pattern, and how to initiate the design. So it's really interesting, and we have learned a lot of things from your side, sir. Thank you. Now the session is open for the participant. Where just unmute themselves. You can ask our question to our expert. So now you can interact with our Dr. G.Saravana Kumar, sir. Or you can post the question in the chat box itself.
So there are few, let me see if I see any
Sir,
question.
one question, that is.
Sorry?
So one question is will be in the chat box.
Sorry, see, Gurpreet Kaur has asked, it is not QFT, it is QFD, Quality Function Deployment. Okay. So it is also called as the House of Quality method. So what we do is like typically, let's say if you take a process, like a manufacturing process, the process gives you the product and there are certain attributes of the product. Let's say I take a lathe, a single turning, turning operation. So the turning operation has several process parameters, like, what is the, spindle speed, or what is the, say the depth of cut. Just to give you an example, a very simple example. Just 1 minute. I'm still in a talk. Okay, I will call back. And there are certain product attributes, like say the surface finish or the cost of doing the turning operation. So how do we connect these two? In most cases, there is no mathematical equation that will connect. Maybe in terms of this single point turning operation, I have a mathematical equation that says that if I increase the spindle speed, what will happen to the surface finish? Or if I increase the depth of cut, what will happen to the surface finish? But when we are doing the design synthesis, we do not know how the different attributes of the product is enhancing the functionality or the attributes of the product, right? So we have to build some relationship, correlationship, which comes from, let's say, the user's feedback, several mechanisms of understanding this relationship. So the QFD is a tool that helps us in creating this mapping between some things that you can control and what you get as an output of that. And this QFD, depending upon where you are using it, you can create those tables. Like the QFD can be applied in the early conceptual stage to later product detailed design. Everywhere you can apply. Okay. So it is also called as house of quality. Okay, I would request you to go through some literature. There are very standard books on the functional and conceptual design, which discusses about this QFD. Okay.
So, sir, is it quality first, something like that? That is what you're referring to?
QFD is quality function deployment.
Okay. Thank you so much, sir. Thank you.
Yeah. Yeah.
Hello, sir.
Yes.
So one question is raised from the participant. Give an example for the agriculture related machine design.
Agriculture, yeah. Let me remember. Yeah, I think we did something on seed sowing the seed. Sometime back we did one exercise of creating a machinery for sowing the seed. So a lot of what should I say? Machinery is required in the agriculture, either for processing the produce or for the various agricultural activity. There are very many mechanized systems that are available which can be used in a Western context. In a Western context, what happens is there are large fields, thousands and thousands of acres of, let's say, plantation of a particular type of plantation, and there you can use machinery which can process this in a completely guided, or most of the activity is taken care of by the machine. But in Indian context, if you will see, the land holdings are small, and there is not too many agglomeration of the farmers. So many of these implements that you can think of could be like semi-automatic, which can reduce the drudgery of the the labor that is involved in this very labor intensive activities. We can always think of, so seed sowing, or de-weeding. For all of this, we have actually designed some components. Like that, you can think of even in the processing, like de-shelling, or de-shelling, taking let's say some fruit or pulp out of the produce. All of this, semi-automatic, or wherever there is intensive labor, we can think of implementing systems which can reduce the drudgery. Not completely automating, because that may not be the solution that may be useful in an Indian context, but reducing the drudgery, reducing the labor, the pain of labor could be reduced, and that is what we have seen. Even we have we have worked on a product, this agarbatti making, if you know. That is also a very manually intensive way, they make it. But there are also very automatic machines, Chinese machines are available, which can kind of, make things in an automatic fashion. But you do not want to see, there are other associated problems. You do not want to replace thousands of those, say small time, household, ladies are mostly involved in NGO kind of setup. You don't want to take away the livelihood of those people. So products have to be designed in the Indian context. In most of the cases, we have seen that if we reduce the drudgery, if we reduce the pain of the labor without replacing the labor itself, those kind of products are probably the candidate problems that we can take. That is what I can tell. Yeah.
So one question from Gaurav Chaitanya. Can you see that question, sir, in the chat box?
Short-term courses on product design. See, sometime back we did it. I don't know, 2015, 16. Yeah, it depends upon my the time availability of me or my colleagues. As of now, no, I don't have a plan, but I readily participate, whenever there is any such initiative done by others. Like in this case, Dr. Tyagu has done this FDP. So wherever, there is an scope in a FDP, I try to share my, ideas and thinking. But right now, I am not planning anything at IIT Madras. Okay. Yeah.
Thank you, sir.
Sir, here Dr. Nilesh Avte from Nagpur, Maharashtra.
Okay.
Sir, we are college was the Center of Excellence Creative Design are available. So in this through the Center of Excellence, we are conducting various product development related activities. Especially, we develop around 16 agro-based projects.
Okay.
So out of them, 2 machines we would like to convert into commercialize, but due to some product development related issue, we are unable to convert this project into products.
Okay.
So also, I share with you, I'm closely associated with Dr. Sandipan Bandyopadhyay sir to the MMI, the machines.
Yeah.
Sir is the chairman of our IPTOM and other.
Yeah, AMM, yeah, I know, because I was the secretary of that for some time, and me and Sandipan, work on several of these things.
Yes.
Yeah.
So through this AMM activity, I closely connected with Sandipan sir.
Okay.
So we need some help about the ergonomic related issues, sir. During the development of some agro-based product, we are working on some of the products. Were clear. Recently, we developed one of the machines, post-dig hole machine and auger. In this machine, some vibration are creating. So we are changed this design and forwarded to Central Institute of Engineering, Agriculture Engineering, Bhopal. This design forwarded to the director for the approval. So we need some help regarding such kinds of ergonomic consideration in the design of agriculture machine.
Okay.
Especially,
So anyway, see, I understand your problem. Maybe we can we can discuss, and we can see if, what will be the best group that can help. There is also you may be knowing about RUTAG, right? RUTAG activities.
Yes.
Rural Technology Action Group. One Professor Abhijit Deshpande is, I think, the chairman in IIT Madras. Like that, I think RUTAG cell will be there in several other institute IITs also. I think there are interest groups even in other places like IIT Delhi, Shaha, you might be knowing. So he is also interested into some these kind of rural machineries. Okay. And so we can identify some groups are connect you through either this AMM platform also to see if who can help you in overcoming the challenges that you have in the product development.
Yes.
Okay?
We always forwarded our paper to IPTOM every year. Every 4 years, sorry. World Congress.
Yeah. Every 2 years we have IPTOM. I think in between probably 1 or 2 times we might not have had it, but yeah. IPTOM, it's actually IPTOM is a good platform. Yeah.
Okay, sir. Okay. Thank you very much, sir. Thank you.
Yeah.
Thank you, sir. So that's all. We are in the end of the session. So a special thank to Dr. G.Saravana Kumar sir for accepting our invitation and presenting a wonderful session. And I also thank all the participants for patiently listening the first 2 sessions of this day 3. I thank all of you. Thank you, sir. Thank you, Sonakumar sir.
Thank you. Thank you for giving me this opportunity and talking to the participants. Thank you. Yeah.
Thank you, sir. So I kind request to all the participants, kindly fill the feedback form, which is posted, is available in the chat box. So feedback is very mandatory for getting the e-certificate. So don't leave without filling the feedback. Thank you.
So thank you.
So, thank you, sir. If you wish, you can sign out, sir. Thank you.
Yeah. Thank you.